Mhm. Mhm. Okay, assalamu alaikum everyone. I hope you're all well. We'll be starting in a couple of minutes, inshallah. Uh, the plan for today is that we are going to do difficult questions from three recent papers, from three papers from 2025. Uh, I have posted polls in the WhatsApp group. You're supposed to respond to them. Let me know the questions you find difficult, and we will do those particular questions from these three papers then, inshallah. Okay, that's the plan. These are free AdMaths past paper sessions that I'm conducting. In the last couple of sessions, we have done March 26 paper and one of the November 2025 papers as well. Today we're doing difficult questions from three different papers. You can see that in the title: November 25 paper 1, paper 1 3, and March 2025. If you want to join these sessions, you can have a look at the link in the description. You can just fill out that form and you'll be added to the WhatsApp group. You'll find a lot of other resources in the description as well, like difficult questions from a lot of other recent past papers as well, a lot of revision videos that a lot of students find helpful before their exams. You can have a look at them as well. Okay, chale. Let's get started. We are doing difficult questions from three papers today. ठीक है March 25 paper 1 2, November 25 paper 1 1, and November 25 paper 1 3. This is IGCSE O level advance. Walaikum assalam, Azim. I'm good, alhamdulillah. I hope you're also doing well. Let's start with some questions then. Acha. What I'll do is I'll look at the WhatsApp group and see which questions have more votes, and we will start with those questions then, inshallah. Chale. So the first paper that we're starting from is March 25, paper 1 2. This is the first paper that I'm starting from. Let me see the polls and see the questions you guys have asked about from this paper, first of all. Acha. So there are a few votes on this question, also on this. All right, chale. Let's start with question number 2 from this. Let's start with question number 2 from this paper. Let's start with that. And then we will do some more after that, inshallah. Let me take a snapshot of that. I'll have to copy the questions side in this class because I'm looking at the polls and deciding which questions we are going to do for this class. So I'll be copying them side. Okay, this is the first one that we're doing. This is question number 2 from this paper, March 25, paper 1-2. Let's do this one. Question number 2 from this paper, that's the first one that has some words. Let's start with this. Acha. The diagram shows the curve. It's not that difficult. It's a very repetitive question that you'll see again and again on trigonometry. Let's start with this one. They're saying the diagram shows the curve y equals a cos bx plus c for x between negative 180 and positive 180. It's given that a, b, and c are integers. Find the values of a, b, and c. Now, how can we find these values? Remember in this form, this number outside that is multiplying, that represents the amplitude for the cos function. The number that is adding outside, that represents the baseline of the graph. It shows how much the graph is translated vertically upwards or downwards. And this number b, this changes the period of the graph, right? The period of the graph. How does it change the period? Or you can also say it represents the frequency. Okay. Achha. Now, what about the value for A? What about the value for A? Where is the baseline going to be? The maximum point is at 3, the minimum point is at -7. Baseline for the graph is going to be exactly between them, between -7 and 3. Where is that point going to be? At -2. This is the baseline of the graph. Okay, this is the baseline. So that tells us the value for C, therefore, is going to be -2. That's easy to figure out, first of all, this value C. What about the value for A? A represents the amplitude from the baseline. What's the maximum distance that we can go vertically? We can go 5 units up, we can go 5 units down. So the value for A that we get from this, the amplitude, that is equal to 5. Okay, the value for A is 5. Then what about the value for B? What about the value for B? What is that going to be? B represents the number of cycles the graph is completing in its one full period. So what's one period? What's a period of cos graph? The period for the cos graph is 360 degrees, the standard cos graph. Now this is -80 to 180. That represents an interval of 360, right? This is an interval of 360 degrees. Now, how many cycles are being completed in this? This is one full cycle, another full cycle, another full cycle. 3 cycles are completing in 360 degrees. That tells you this number B, that is going to be 3. The value for B is going to be 3 for that reason. Okay? You can also think of it like this. Find the period of this graph. What's the period of this graph? You can see it's 3 complete cycles. So that means 360 over 3. The period of this graph is 120. So the original period is divided by 3 to get to 120. The value for B, therefore, is going to be 3. That's the value for B. Okay. Should you start your preparation for A-level Maths P1? Definitely. If you don't have any other exams, you should start with that. Because it is happening on 9th, you should do the other exams preparations as well, because most likely they will be retaken as well. S1 and P3. Chale, that was question number 2. Let's move on to the next one. Okay, next one from this paper. The next one from this paper that you guys have asked about is question number 6. Question number 6 from this paper, let's have a look at that. Question number 6. Let me copy that here. Question 6 from this paper. Okay, this is the next one now. Question number 6. This is the next one from this paper that you guys asked about. Let's do this now. This is the first part. You can think about it in the meantime. I'll copy the other parts. This is part A. Then this is part B. And this is part C. Achha. This is the next one that you've asked about, right? Question number 6 from this paper. Let's try this now. Now, this is another question that you'll see a lot now in non-calculator papers. They give you the value for one of the three trigonometric ratios. In this case, they give you the value for tan. Sometimes they will give you the value for sine or cos. Given that, they will ask you to find the value for some of the other ratios. So in this case, they gave you the value for tan, and you're supposed to find the value for cos, the value for sine. How do you deal with such problems? There are two ways of thinking about these problems. One is using a right angle triangle, and the other is using identities. Let me show you both ways, and then you can decide whichever of the two methods you prefer. So one is using a right angle triangle, and that is, you say, since tan theta is equal to under root 5 over 5, how is tan defined? What's the definition of tan? Tan is defined as opposite over opposite over adjacent, yeah, perpendicular over base, right? So we can think of it as perpendicular over the base. Make a right angle triangle. Make a right angle triangle. You can. It's not necessary to actually make that triangle, but think of right angle triangle. It would look like this. Now, what we know is the ratio between perpendicular and base. The ratio between perpendicular and base, what's that? That is under root 5 to 5. Which means if, for example, this value here was theta, if this value was theta, we're talking about the basic angle. Let's actually call this alpha, the basic angle. If the basic angle was alpha, the perpendicular is under root 5 and adjacent is 5. Now, what about the hypotenuse? Can we find the value for hypotenuse from this? We can do that, right? We can say hypotenuse square, that would equal square root of 5 squared plus 5 squared, and that gives us 5 plus 25, which is square root of 30. That's the value of the hypotenuse that we end up getting from this. Okay. Now the hypotenuse is square root of 30. Now we can write down the value for cos of alpha, the basic angle. Let's write down the value for cos of alpha. Let's see what that turns out to be. The basic angle, that's what we're talking about. Based on this triangle, we know the value for hypotenuse, right? That is square root of 30. Cos is defined as adjacent over hypotenuse, or base over hypotenuse. Base is 5, hypotenuse is this. So the value for cos would be 5 over under root 30. That's the value of cos that we get. Okay? That's the value of cos. Now you have to be a bit careful. You have to think about the sign for cos as well, whether the sign for cos is going to be positive or negative. How do we figure that out? The question tells us it's an obtuse angle. It's a reflex angle. It's a reflex angle between 180 and 360. Now, if it's a reflex angle, which quadrant are we talking about? Which quadrant can we be in? If it's a reflex angle, we can be in third or fourth quadrants between 180 and 360. So we could either be here or we could be here, right? And any of those two quadrants could be possible. Now, ASTC, we have already eliminated the first two. They are not possible. We could be in any one of these two quadrants. But also notice the value for tan is positive. The value for tan is positive. Where is tan positive? Tan is positive in the third quadrant, not in the fourth quadrant. So that tells us the fourth quadrant is also not possible, therefore, and we are actually in the third quadrant. This is the quadrant that we are in. The value, the theta, the angle theta is in this quadrant, in the third quadrant. Now, if it is in the third quadrant, we know, if it's the third quadrant, we know cos is negative in the third quadrant. So it will be negative 5 over under root 30. That's the value of cos theta that we get. Yes, this is March 25. This is March 25, paper 1-2, yes. We're starting from this. Then we do November 25 papers after this. Is this clear to everyone? Any issues with this? That's the value of cos theta. Okay. You could simplify this. You could simplify this as well. You could maybe write it like this: -5, and then the denominator you could split as under root 30 is under root 5 into under root 6, and that will give you -5 over under root 5. That will become minus under root 5. So you could write this as minus under root 5 over 6. But this is also acceptable. In the marking schemes, they would generally say one answer and then anything equivalent to that, that will also be acceptable. Okay, that's the value of cos that we're getting. Achha, now, if we use the same method for the next part as well, where they ask you for sine theta, now we can write down the value for that directly, right? We made that right angle triangle. In that right angle triangle, what is perpendicular? What's the value for perpendicular? The value for perpendicular is under root 5. And what about the hypotenuse? That's under root 30. So sine, therefore, is going to be under root 5 over 30. Right, under root 5 over under root 30, that's under root 5 over 30. We can simplify this, and that will give us under root 1 over 6. But now, which quadrant is this in? It's in the third quadrant. In the third quadrant, sign is negative. So we put a negative sign with that. We say it's negative square root of 1 over 6, and that's our final answer. Okay. This is one way to approach such problems using right angle triangles. It works every time. You can do it like this. Make sure that you know which quadrant you are in. So you can write down the positive or negative sign in accordance with that at the end. Okay. Another way to deal with these problems is using identities. That's another possibility. You can also use identities for such problems. Now, how would you use identities? We are given the value for tan theta. We are given the value for tan theta. Tan theta is under root 5 over 5. That's the value that we're given. We want to find the value for cos theta. Now, one identity that we have is tan theta is sine theta over cos theta. Is that going to help? Not really, because we have two functions in that, sine and cos. So that's not going to be very helpful, right? We have another identity for tan. That is 1 plus tan square theta. That is identical to secant square theta. And remember, secant is reciprocal of cos. That could be one identity that you could use here. So you would say 1 plus tan square theta, that will become under root 5 over 5 whole squared. Now, this is the value of secant square theta that you would get. Let's simplify this. It becomes 1 plus 5 over 25, which will be 1 plus 1 over 5, right? 1 plus 1 over 5, that is secant square theta. And then it becomes 6 over 5, that is secant square theta. Take square root on both sides. That gives you plus minus square root of 6 over 5. That equals secant theta. You were looking for cos theta, so take reciprocal. Cos theta will become plus minus square root of 5 over 6. Now we have to decide between plus and minus. We know. We figured that out earlier. It's supposed to be in the third quadrant. For that reason, we put only the negative sign with this, not the positive sign, and we say therefore cos theta is going to be negative square root of 5 over 6. And that's the same result that we got here as well. This is another way of doing this, using identities. Okay. Now, once you've got cos theta, we already had tan theta given. You can use identities now to find the value for sine theta as well, right? So if you wanted to use this identity method, you could say, once you've got tan and cos, you can use tan theta identical to sine theta over cos theta, input values in that. What was the value for tan theta? Tan theta was under root 5 over 5. Tan was under root 5 over 5. That equals sine theta divided by cos theta. What's the value for cos theta? that we found minus under root 5 over 6. Rearrange this and that will give you the same result as before, which is minus square root of 1 over 6. And that's the result that we were getting earlier as well. Okay, can permutation and combination come in paper 1? Yes, it can definitely come. Mostly you'll see questions where they ask you to simplify something like this NCR and using factorials. But they can ask some other standard permutations and combination question as well. What would happen in that case would be that you would get smaller numbers that you can calculate manually without needing a calculator. But definitely you can get other types of permutations and combination questions as well. As long as calculation is simple that you can do without a calculator, it can be tested. ठीक है, चलें, let's move on. So these are two different ways of approaching problems like these, where they give you one function and you have to find the value for another function. Achha, what about this now? Find the value of secant theta plus cot theta, giving your answer in this form where a, b, and c are integers. Now, what about this? Secant theta plus cot theta. We already know the values for sine, cos, and tan. We have found them in the previous parts, right? We know the values of sine, cos, and tan. Secant can be written as 1 over cos. Cot can be written as 1 over tan, or you can say cos over sine. Any of them would work. Since we know the values already, let's just input it like this. What's the value of cos theta that we found earlier? Cos was this, right? Minus under root 5 over 6. So here, it will become reciprocal of that. I'll write them separately, minus under root 6 over under root 5. It's just the reciprocal of this number, right? Secant is reciprocal of this, minus under root 6 over 5. Okay. Then what about this? Cot. Cot is reciprocal of tan. Where was tan? Tan was given to be under root 5 over 5. Take reciprocal of that. And that becomes 5 over under root 5. Okay, that's the value for tan, 1 over tan. Now you simplify this. Both have the same denominator. Both have the same denominator. You just add them up together. They want the answer to be in this form. Now, that's straightforward because it's already in that form. You just have to take LCM. In the denominator, you would have under root 5 here. In the numerator, you want the constant without the square root first. So you'll say 5, write that first, and then you have minus under root 6. And that's your final answer. This is what they wanted you to figure out in this question. ठीक है? Makes sense to everyone? That was the next one that you guys asked about from this paper. There are two more questions from this paper, questions 10 and 12. Let's have a look at those now. So in the poll that I posted in the WhatsApp group, there are two other questions that you guys asked about, questions 10 and 12. Let's look at them. Questions 10 and 12. Let me copy question number 10 here now. Well, that's a 9-mark question. Okay, let's do this now. Question number 10. The point P lies on the curve, this curve. The x coordinate of P is 5. The normal to the curve at P intersects the line x plus y equals 11 at the point Q. So P was given in the question, and the x coordinate of P was given. There's a normal to the curve at P that intersects another line at the point Q. The point R is a reflection of Q in the tangent of the curve at P. Find the coordinates of R. That's a 9-mark question. That means it's going to require quite some working. Let's think about it. First of all, we are given the x coordinate of the point P. Can we find the y coordinate of this? Let's start with that. Let's find the y coordinate of the point P and see what that turns out to be. 5 into 5, because we need that point to find the equation of the normal, right? So let's find the y coordinate. 5 into 5 plus 2 whole raised to the power 2 over 3. Let's simplify this. Inside the brackets, we get 27. So we have 27 raised to the power 2 over 3. Now, how do you evaluate this? You can evaluate the cube root first. 27 raised to the power 1 over 3. Evaluate that first, and then you square that. Cube root of 27 is 3. 3 squared is 9. So the value of y turns out to be 9. The point P therefore is 5 and 9. These are the coordinates of the point P. Okay. We know the point P now. Now they're saying there's a normal to the curve at P that intersects this line x plus y equals 11 at the point Q. Let's find the point Q now because R is the reflection of Q. So we need the point Q to be able to find the reflection of R later on. How do you find the point Q now? Q is the point of intersection of the normal and this line. How do you find points of intersection? We solve the equation simultaneously. We have one equation given already. For the other equation, we can find the equation of the normal, and then we can solve them simultaneously. Let's find the equation of the normal at that point now. How do you find equation of normal? You need two things for that. A point on the normal, that is this point, that's already given. We also need the gradient. For the gradient, we would need to find the derivative of that original curve. Okay? So that we can find the gradient of the curve at that point, and then the gradient of the normal is just going to be negative reciprocal of that. Okay. Let's find the derivative of this and see what this turns out to be. dy over dx. Multiply by the power, subtract 1 from the power. Yeah, that becomes negative 1 over 3, right? 2 over 3 minus 1, that's negative 1 over 3. Multiply by the derivative of the base, derivative of 5x plus 2, that is 5. That's dy over dx. Now, let's simplify this. 2 into 5, that is 10. And in the denominator, let's make this power positive. Since we don't have a calculator available, we want to simplify calculations. Let's make the power positive. Okay. In the denominator now, I have 3 into 5x plus 2 whole raised to power 1 over 3. We want to find the gradient at this particular point. For that, what I can do is I can input x equal to 5 in this derivative. Let's see what this turns out to be. dy over dx. This gives us 10 over 3 times 5 into 5 plus 2 whole raised to power 1 over 3. Achha. Now, in the denominator, we have 3 here. This is 27 cube root of that. 1027 power 1 over 3, that's cube root. So we have 10 over 3 into 3, which simplifies to 10 over 9. Now, this is the gradient of the curve at that point. Now, if this is the gradient of the curve at that point, what that means is the gradient of the normal is going to be negative reciprocal of this, which is negative 9 over 10. That's the gradient of the normal. Okay. That's the gradient of the normal. Makes sense? Any issues with this? Well, you get questions on every single topic in paper 1. There's no topic that is not tested in paper 1. There is no topic that is not tested in paper 1. So don't skip any topic thinking that it will not be tested in the non-calculator paper. You'll find questions from every single topic in the non-calculator paper as well. So you can't skip anything. Okay? So don't think like this that you can skip something because it will not be tested here. It will just be that they would ask you to find exact answers when they come in non-calculator papers. And you'll have some relatively smaller numbers to deal with. Achha, we've got the gradient of the normal now. Let's write down the equation of the normal. We have a point and we have the gradient of the normal. We have the gradient of the normal. Let's write down the equation of the normal now. Y minus y1 equals m into x minus x1. What does that turn out to be? Y minus 9. That is equal to minus 9 over 10 into x minus 5. Okay. That's the gradient, that's the equation of the normal. Let's simplify this. I'll multiply 10 on the other side, or maybe not. Let's write down the other equation. What was that? X plus y is equal to 11. We have to solve this simultaneously with x plus y equal to 11, right? What we can do for that is we can just make x the subject here directly. Okay, let's actually make y the subject from this equation and put that here. Okay, so what I'll do is I'll multiply 10 here. I'll multiply 10 here. So I was just thinking how the calculation will be simpler so we can avoid fractions. Let's multiply 10 here. 10y minus 90, that gives us minus 9x plus 45 on the other side. Now, do not make y or x the subject from this equation because that will make you deal with fractions. You want to avoid them as much as possible because that will simplify your calculations. From the other equation, you can say y equals 11 minus x. And that is what you can input in the first equation now. Now, what does that give us? 10 into 11 minus x minus 90, that is equal to minus 9x plus 45. 10 into 10 into 11, that is 110 minus 10x minus 90 equals minus 9x plus 45. 10 goes to the other side and that gives us x. 110 minus 90, that is 20. 20 minus 45, that is giving me negative 25. That's the value of x that I'm getting from this. Okay, let's input this back in the other equation to get the corresponding value for y and see what that turns out to be. The value for y is equal to x plus y is equal to 11 minus x. So y equals 11 minus 25, and that gives us 36. The value for y is 36. Now, what have we found here? We have figured out the point Q, this point Q. This point Q is negative 25 and 36. That is what we were looking for. Okay, that's what we're looking for. For stress management before the paper, the most important thing is that you have a good night's sleep. That's important. Do not stay up for stay up until very late at night. That's very important. You want at least 7 to 8 hours of sleep before a math exam. Otherwise, even the stuff that you know, you end up making errors on that. So before the exam, that is very important. Try to keep yourself relaxed in the last hour or so. Do not practice any new questions on the day of the exam. In the morning, do not do any additional practice. The most you can do is do some revision, right? You should not be practicing something hands-on on the day of the exam. During the exam, make sure that you do the questions that you know first of all. So in the first pass through the paper, attempt all the questions that you can easily figure out without spending a lot of time. Okay, that will make sure that you are not missing out on any easy marks because you ran out of time at the end of the paper, and that will increase your confidence during the exam as well. So, for example, if you're able to do 7, 8 questions in the first go, in the first maybe 45, 50 minutes, because if they're easier questions, you will be able to save time on them as well. And then for the relatively more difficult questions, there may be like 3 relatively more difficult questions or 4 relatively more difficult questions, you'll have enough time later on to be able to slow down a little on them, maybe think a bit more deeply, and that will calm your nerves as well. If you still end up panicking, just stop for a while, maybe half a minute, do some deep breathing, and that helps. And then you can restart the paper after that. Okay, but that's very important for time management and stress management. This is extremely important that you do not get stuck at any particular question in the middle of the paper. That's the most crucial thing that ends up messing up the exams for a lot of good students as well, that they spend a lot of time on a difficult question in the middle of the paper, because of which they are left with very little time for the remaining questions. And when they try to rush through the rest of the paper, they end up making careless mistakes. So at least 2 passes through the paper. That's what you should do. In the first pass, you need to attempt all the questions that you can easily figure out. without spending a lot of time. And the second part is then you deal with the relatively more difficult questions. Your confidence will also be much higher at that point because you would have attempted at least like 7, 8 questions or maybe 9, 10 questions for the better prepared students. And you'll have enough time for the more difficult questions then. Okay, so that's what I said. Save time on the easier questions, Sheroz. Save time on the easier questions, and then you'll have more time for the more difficult questions. You'll be able to slow down a little. And when you're able to slow down a little, make sure after every few steps, you check what you have done in the previous steps. Don't spend a lot of time on that, but after like 3, 4 steps, have a quick glance over what you've done until that point, maybe a couple of seconds, and make sure that you're not making any plus minus mistakes there. Okay, or maybe any other mistakes like opening some bracket wrong or stuff. You should do that as well. Okay. Achha. And ideally, at the end of the exam, you should have like 7, 8 minutes or 10 minutes to recheck the whole paper as well, because still mistakes will happen. Mistakes happen with for the best students as well, as in they end up making mistakes as well. The way to figure them out is that after every single question that you're doing, have a quick look at the paper, at that question, because that's the best time to be able to spot an error right after you're done with the question. But at the end as well, then save around 10 minutes if you are able to. You should actually try and practice the past papers at home the same way as well. कि जब आप कर रहे हैं तो आपके पास end पे 10 minutes हो जिसमें आप paper recheck कर रहे हो. If you make that habit your habit at home as well, that is what is going to help in the actual exam. ये नहीं होगा कि exam में जाके आप पहली दफा ये कर रहे हो. You should practice this at home as well in the remaining papers that you're attempting now. Paper ones, generally they're doable within time. They don't take a lot of time. Unless you end up getting stuck at a question, that's different. But otherwise, it's not very difficult to manage time well. So you should have time at the end to be able to recheck your paper. Achha, we found the point Q now. We find the point Q. Now we are looking for the point R, that is reflection of Q in the tangent into the curve at the point P. Now, how do we think about this now? How do we think about how to find the point R? It helps to make a rough sketch of the situation that will make you understand the question better. Now, we don't know what the shape of this curve is going to be, but just for understanding, let's make a random curve. Let's say the curve looked like this. Now, this is not the actual shape of the curve. I'm just drawing something randomly, maybe something like this. Let's suppose this was the point P at which we had the normal drawn. Now, we know the coordinates of the point P. What were the coordinates of point P? 5 and 9. Okay. At the point P, we had a normal. We had a normal like this. Now, on this normal, there is a point. On this normal, there is a point Q. That has coordinates -25 and 36. Let's mark that point somewhere. Let's suppose it is here. Let's suppose this is the point Q. This is -25 and 36. Okay. You want to find the reflection of Q in the tangent to the curve at P. Now, what would the tangent at P look like? The tangent at P would look something like this. Remember, tangent and normal, they are perpendicular to each other. Now, what will be the reflection of that point Q in this yellow line? That will be some point here exactly on the other side of that tangent, this point R. And this point R will be such that P is the midpoint of QR, right? When we talk about reflection, the perpendicular distance from the line of reflection on one side, it should be the same as the perpendicular distance on the other side. So P is the midpoint of QR. Now, if P is the midpoint of QR, we can figure out the point R either using the midpoint formula, or there's a more efficient way of doing this using the vector method. And that will go like this. This is point Q. You have the point P as well. The point P was 5 and 9. Just think of it like this. How many units do you have to go in order to go from negative 25 to 5 plus 30 units? You go plus 30 units more, and that will take you to the point R, which is 35. That's the x coordinate of R. Similarly, how many units do you have to go in order to go from 36 to 9? 36 minus 9 is 27, right? So you have to go minus 27 units. You go minus 27 units more. 9 minus 27, what does that give you? Minus 18. These are the coordinates of the point R that we were looking for. And that's our final answer. Is that okay? Any issues with this? ठीक है. That was question number 10 that you guys asked about. Now the last question from this paper is question number 12. And then we move on to November 25 paper after this. This was question number 10. That was 9 marks, required some thinking and some working as well. So it was not very straightforward. Let's look at the next one now. Okay, next one is question number 12 from this paper. Let me copy that here as well. Question number 12. Okay, this is the next one that you guys are asking about. Okay, this is an integration question, very similar to one that we did in the last class as well. Let's try this. The first part is differentiation, but I assume that that is not where you have the problem. You are probably stuck at the second part, right? Okay. Chale, let's do this now. Question number 12. In the first part, they're saying find the derivative of this function. It's a product. So how do you differentiate it? You have to use the product rule, right? Product rule, it will be u into v. Product rule says the derivative is going to be uv dash plus vu dash. Just input values in that dy over dx. U remains as it is, that means x remains as it is, into derivative of e raised to power 3x plus 2, that will be e raised to power 3x plus 2 as it is, into derivative of 3x plus 2, which is 3, plus vu dash, v as it is, that means e raised to power 3x plus 2 as it is, into derivative of x, which is 1. Simplify this, and that gives you x e raised to power 3x plus 2 plus e raised to power 3x plus 2. That's the derivative that we're getting in the first part of this function. Okay. Now, once we've figured this out, they are saying, these were easy 3 marks. Now they're saying, hence find this integral. Now, this is something that's repeated a lot in recent papers. Let's understand how to do this. Hence means you have to use the previous part somehow, because otherwise it's a product. We don't know how to integrate products, right? We don't know how to integrate products. If they asked how to integrate this directly, you can't do that. This is not part of AdMath syllabus. You will understand how to do it in A-level maths paper 3. This is done using integration by parts. This is done using integration by parts. That's the product rule of integration, but that's not part of AdMath syllabus. That is why they are making you use the previous part here. Okay, you can't do it directly at this level. Okay. Now, how do you do it using the previous part? In the first part, what we have done is we have said this expression, when we differentiated x e raised to power 3x plus 2, the result that we get from that is x e raised to power 3x plus 2 plus e raised to power 3x plus 2. That is what we're getting when we differentiate this thing. Now, how do we use that to integrate this now? X e raised to power 3x plus 2. You see, we have exactly that same thing appearing on the right side here as well. What we do in such problems is we say, let's just integrate the whole equation. Integrate this whole equation with respect to x. So integrate the left side with respect to x, integrate the right side with respect to x. We can integrate both of them individually like this, right? Now, when we integrate the left hand side, we are saying integrate with respect to x, and inside we have the derivative with respect to x. Integration and differentiation, they are opposite of each other, so they kind of cancel each other's effect. What are we left with? We are just left with x e raised to the power 3x plus 2. Okay? On the left side, because they kind of cancel each other out. On the right side, what about this? We don't know how to integrate it. We just leave it as it is. X e raised to power 3x plus 2. Notice this is exactly what they want us to integrate. We will leave it as it is for now. What about this? Do we know how to integrate this? E raised to power 3x plus 2? Yes, integration for this is going to be e raised to power 3x plus 2 divided by 3. Now this term, it's exactly what we want. All we have to do is make this thing the subject. Take everything else to the other side. So you say x e raised to power 3x plus 2 minus e raised to power 3x plus 2 divided by 3. That equals integration of x e raised to power 3x plus 2. And that's what we wanted. We can change the order, maybe write that thing on the left side. X e raised to power 3x plus 2 integration of this is given by x e raised to power 3x plus 2 minus e raised to power 3x plus 2 divided by 3. This is the final answer, so make sure to write plus c as well. Okay, make sure to write plus c there as well. Okay, I'm sorry, there was a 3 there. Okay, I'm sorry about it. I missed that. Okay, I'm sorry, there's an error there. There was a 3 here as well. There was a 3 here as well. I forgot to multiply this at the end. There was a 3 there as well. I'm sorry about that. There was a 3 there, so we have a 3 here as well then. Okay, so we have a 3 here as well. And then we have a 3 here as well. We divide that on the other side, so it'll actually become this divided by 3, and this will become 9. Okay, so that's what it would be. So I missed a 3 in the previous part. It was multiplying there, right? I, for some reason, forgot to copy that in the next part. ठीक है. Paper 3 for people outside Pakistan, it will be retaken if you make enough noise, otherwise they will ignore it. So make sure that you make a lot of noise, make posts online, send them emails, send emails to British Council in your country or whoever conducts the exams in your country. Make sure to do that and make them accept that it was leaked. Otherwise, they might just ignore it. So make sure to do that. Okay, that's the integration that we get at the end. Makes sense, right? This 3 that we had, it doesn't matter if we write that outside the integral or inside the integral, it's just multiplying, right? The 3 was just multiplying. So it doesn't matter if we write it outside or inside. So at the end, all we have to do is just divide it on the other side. So I just divided that 3 on the other side there, and that gave me this. Okay. Achha, that was question number 12. That was question number 12. Let's look at the next paper now. These were all the questions that you guys asked about from this paper. Let's do the next paper now. Let's do the next paper. When integrating, when do we add an x with the constant and when do we move the constant outside the integral sign? If we have something like this, if we have an integration of maybe 3 into x plus 5 whole raised to power 2 over 3 with respect to x, this constant is multiplying. This constant is multiplying. So we are allowed to write it outside the integral. We can write it as 3 into integral of x plus 5 whole raised to power 2 over 3. Why do we do that? Because this is a number that is multiplying. When you integrate, this number is not going to change. Nothing will happen to this number, okay? This number will remain unchanged. So it doesn't matter if you write it inside or outside, you'll get the same result either way. However, if you had something added or subtracted, so for example, if you wanted to integrate 5x squared plus 7 with respect to x, now in this case, this 7 is being added. This is a separate term. In this case, we can't write the 7 outside, we have to integrate it. Okay, so we have to integrate 7, and its integration is going to be 7x, and the first one is going to be 5x cubed over 3. In this case, 3 was multiplying with this term. When you have a constant multiplying with the whole thing, you can write that outside. If it's being added or subtracted, then you cannot write that outside. Okay, I hope that answers the question. Okay, let's look at this one, this paper now. November 25, paper 1-1. November 25, paper 1-1. Let's do some questions from this now. I'm just opening the polls for this paper. Which questions did you ask about from this paper? November 25, paper 1-1. Let me open that here as well. From this paper, we have questions 4, 5, 9, and 12. Let's do these 4 questions from this paper now. Question number 4. Let's start with that. Question number 4 from this paper. Okay, that looks interesting. Copy that here. Okay, question number 4. This is one question from this paper that you asked about. There's another part to this as well. Let me copy that as well. Part C. Okay, not just one other part. There are 2 other parts. Let's copy the whole thing here. Okay, so this whole question looks like a pretty good one. There are some very important concepts tested in this. All right, chale. Let's look at this. First of all, part A of this question. This is November 25, paper 1-1. We're doing difficult questions from this paper now. Explain why this graph does not represent a function. Why this graph does not represent a function. Now, what's the condition for something being a function? The output should be 1, right? So many to 1 and 1 to 1. These are the only 2 types of functions. Many to 1 or 1 to 1. Is this any one of those 2 types? This is many to many, right? For one value of x, you can get multiple y's. For one value of y, you can get multiple x's. So it's a many to many function. It's a many to many relation. It's a many to many relation. That is why it's not a function. Functions are only 1 to 1 and many to 1. You could also say it fails the vertical line test, right? For a function, we also have this vertical line test. If the graph, if you can draw any vertical line that crosses the graph at more than 1 point, you would say it's not a function, right? So you could also say that. That's also a valid explanation for this. You could say it fails the vertical line test. You can draw at least one vertical line cutting the graph more than once. If a vertical line cuts the graph at more than 1 point, that means it's not a function, right? It fails the vertical line test. Achha. Now, what about the second part? We have this table that shows the graph of 4 different functions. Okay, this function, cubic, then you have a straight line, this seems to be a quartic function, and then we have some other kind of function like this. Take each correct box in the table. There may be more than one tick in a row or a column. Okay. The columns are 1 to 1, many to 1, and the function is its own inverse. Okay, how do we think about this now? How do you figure out if a function is 1 to 1? How do you figure out if a function is 1 to 1? Horizontal line test. Let's start with that first. Horizontal line test, 1 to 1 and many to 1. We already know it's a function, so it's going to be one of these two, either this or this. How do we check for that? Horizontal line test. For the curve, you can draw this horizontal line that cuts the graph at more than 1 point. So it's not 1 to 1, it's many to 1. That's for this one. Okay. I'm just focusing on these two for now. So what about this? It's a straight line. Straight lines are 1 to 1. What about this? You can draw this horizontal line, cuts the graph at more than 1 point. So it's many to 1. You cannot draw any horizontal line that cuts the graph at more than 1 point. And the last one, this is 1 to 1. Okay. So for 1 to 1 and many to 1, we can just use the horizontal line test, and that tells us which of the 4 graphs is 1 to 1 or many to 1. How do we figure out this thing? The graph is its own inverse. The graph is its own inverse. That means if you were to find the inverse of this function, you get the same function back. Now, graphically, what that means is, remember, a function and its inverse, they are a reflection of each other in the line y equals x. If the function is its own inverse, what should happen should be, if we were to reflect that function in the line y equals x, we should get the same graph back. If we reflect in the line y equals x, this is the line y equals x, we should get the same graph back. Now, do we get the same graph back in this case? This is clearly not going to be the same graph, right? The first one, it's not going to be the same. The second one, if we draw y equals x line, now, if you reflect this graph in this line y equals x, what happens is the part above the graph, the part above the y equals x line, that becomes the part below the line, and the part that is, let me actually shade that. When you reflect it, the yellow part becomes the blue part becomes the yellow part. So in this case, the graph is its own reflection in y equals x. So we could say it is its own inverse for that reason. Okay, so in this case, that property is true. What about this? Y equals x line is is this its own reflection? No, clearly. You have different shapes on both sides. What about this? Is this its own reflection? Again, no. The reflection would be something like this. So this is also not its own reflection. So the last property is only true for the second graph, and that's your final answer. Okay. Let's move on. Part C. Okay, now that's a lot of information. We have a function f and we have another function g. They are defined as follows. F of x is sine x, and it's defined for x is defined for this interval 30 to a. G of x is this function, x is greater than or equal to 1 over 2. It's given that the function gf exists. Okay, the function gf exists. Find the value of a so that the domain of gf is as large as possible. We want the domain of gf to be as large as possible. You're also given that sine theta is 1 over 2. They mostly give you these values in the paper, but it's still a good idea to remember those values for 0, 30, 45, 60, 90, because Cambridge people, they tend to be unreliable sometimes. So you can't trust them that they will always give you these values. It's a good idea to remember them anyway as well. Okay. Achha. Now, f of x is sine x, g of x is this. Find the value of a so that the domain of gf is as large as possible. So we want the number a to be as big as possible, right? Why? Because remember, they're talking about gf function. It's a composite function. What's the domain of a composite function? Domain of a composite function is the domain of the inner function. So if we have this function gf, we can say g is the outer function and f is the inner function. Domain of the composite function is the same as the domain of the inner function, which is domain of f. Okay? Now, domain of f is this. So we want this domain to be as big as possible. That means the value for a to be as big as possible. Now, how big can this value be? What would the function gf be? Let's write down the domain and range of those original functions here first of all. Domain of the original function and the range of the other function. Let's write them like this. This is f of x and this is g of x. Acha, what do we know about f? For f, we know the domain is from 30 to a. That's the domain for the function f. For this composite function to be formed, for gf to be formed, remember the condition? The condition is the range of the inner function. Range of the inner function, what's the inner function in this case? F. Range of f, it should be a subset of, it should be a part of the domain of the outer function. It should be a subset of the domain of the outer function. What's the outer function? Outer function is g. Now for g, we know that x is supposed to be greater than or equal to 1 over 2. Domain of g, let me just write it like this. Range of f is supposed to be a subset of domain of g. Range of f is a subset of domain of g. Now what do we know from both of them? We know the domain of g. The domain of g is x greater than or equal to 1 over 2. If that's the domain of g, that tells us that the range of the function f, that means the y value for the function f, that has to be at least greater than or equal to 1 over 2. Okay? Because the result, the output that you would get from the function f, you have to input that in this function. And this function is only defined when x is greater than or equal to 1 over 2. That means the y value of this function has to be greater than or equal to 1 over 2. Which means sine x has to be greater than or equal to 1 over 2. The value for sine x needs to be greater than or equal to 1 over 2. Only then the function gf can exist. Right? I'll show you these conditions if you do not remember them. Function, composite function. These are the conditions, right, that you need to remember. A composite function can only exist when the whole range of the inner function is part of the domain of the outer function. It's the subset of the domain of the outer function. And also, if a composite function has been formed, domain of composite is the same as domain of the inner function. You need to remember these conditions. That's what we're using there. So sine x is supposed to be greater than or equal to 1 over 2. Now you can just think of the graph of sine x, because we know it looks something like this, right? This is the graph of sine x from 0 to 360. This is 0, this is 360. We know this is 180. We have 1 at this point. At 30, we are given the value is 1 over 2. Sine 30 is 1 over 2. So this value is 1 over 2. So we want the sine function to be greater than or equal to 1 over 2. We are looking for this part of the graph. What will be the value here? The maximum possible value. This is 30 degrees from the origin. Using the symmetry of the graph, this value here needs to be 150 degrees. Right? 180 minus 30 in the second quadrant. That's 150 degrees. So therefore, the value for A, that is going to make the domain as large as possible, because then the domain will go up to 150. You can't go any further than that, because if you go further, the sine x value will become less than 1 over 2, and then the function gf would not exist in that case. So what's the value of A that we get from this then? The value of A that we get is 150. This maximum value, it needs to be 150 degrees. Now this was pretty complicated. Let me know if that makes sense. Is this okay? Any questions on this? Once you have practiced a number of questions like this, it becomes kind of easier. But if you haven't seen questions like these before, remember those properties that I showed you. A composite function can only be formed. A composite function can only be formed if the whole range of the inner function is part of the domain of the outer function. Okay, and that's the property that we're using there. Achha, let's move on to the next part. Now they're saying, for the domain found in part 1, find the range of the function gf. Now, what's the function gf? Let's just write that down. Gf function, g of f of x. That means g of sine x. That will be square root of sine x minus 1 over 2. That's the function gf of x. What's the domain? 30 to 150, right? 30 to 150, that's the domain of the function. Okay, so the domain of this function is from 30 degrees to 150 degrees. Now we know from 30 to 150, we drew that graph there as well, right? What's the range of the sine function? What's the range of the sine function? What's the maximum value of sine and what's the minimum value for sine in that domain that was given? The maximum and minimum possible values of sine, they were from 1 over 2 to 1. Sine x had a value between 1 over 2 and 1. Okay? So all we have to do is see what this function gives us when sine x is equal to 1 over 2 and what this function gives us when sine x is equal to 1. That will give us the two extreme values of this function. So we put sine x equal to 1 over 2. That was the least value on that sine x graph, right? That will give us the least value of this function, gf of x. What will this become? Square root of 1 over 2 minus 1 over 2, and that gives us 0. Then you input the other extreme value of sine x, which is 1. Input sine x equal to 1, and that gives us gf of x equal to square root of 1 minus 1 over 2. And that is square root of 1 over 2, or you can say 1 over square root of 2. So what's the range of this function then? You'll say y is between, we had equal to sign with both of them, right? Yeah. So we'll have equal to sign with both of them here as well. Between 0 and 1 over square root of 2, that's the range of this function gf of x that we were looking for. Okay. That's the range of this function. Let's move on. Now they're saying determine whether g squared exists. Determine whether g squared exists. How do we determine this now? G squared. Now, what is the function g squared? G squared is g of x. G squared is g of x. Now, what's the inner function in this case and what's the outer function in this case? What's the inner function and what's the outer function? G is the inner function and g is also the outer function. Now, what's the domain of g? What's the domain of G? And what's the range of G? Let's write them down. Because the whole range of G should also be part of the range of G. Now, what's the domain of the function G? Let's figure that out. Domain of G, that's given, that's greater than or equal to 1 over 2. And what about the range? Let's write it in this order, because range of the inner function, we need to be able to put that in the domain of the outer function. What's the range of G now? What about the range of G? Range of this function. It's a one-to-one function. Square root of a linear function is generally a one-to-one function. Its graph looks something like this. But if you don't know that, at least what you can figure out is you can input 1 over 2 in this, right? If you input 1 over 2, what's the value of G that you get from this? What's the value of G that you get from this? If you put 1 over 2, G of x becomes 0 in that case. If you input 1 over 2 there, right? G of x becomes 0. Now 0 is something that we cannot input here. It's not greater than or equal to 1 over 2. So that means we have a problem. We have some outputs from the function G that we cannot input in that same function G. So G square for that reason is not going to exist. So the range that we actually get for this function there, range of G from this function, if you put 1 over 2 there, you get 0. If 1 over 2 is, if x is very large, it will go up to infinity. So the range is going to be from 0 to infinity, or you can just say y greater than equal to 0. Now, some of these values cannot be input here, right? If it's a value between 0 and 1 over 2, you cannot input it in the function G. For that reason, you would say G squared does not exist. Now, that's the sentence that is going to earn you that 1 mark. G squared does not exist. Why does it not exist? Because the whole range of G is not within the domain of G. Okay, whole range of the inner function is not within the domain of the outer function. For that reason, G inverse does not exist. You could also say range of G is not a subset of the domain of G. For that reason, the G square function does not exist. Okay, I think this was a very good question on functions. It tests a number of concepts on functions. Make sure that you understand it very well. Okay, that was question number 4. The next question that we're doing from this paper is question number 5, and then 9 and 12, inshallah. But we'll have a break now for namaz. And then we come back in about 10-15 minutes, inshallah. Let me just copy that question here. So maybe if you want to try that, you can do that. Although the next question does not look very difficult. This arithmetic and geometric progression question. Why did some of you ask about it? So let me see. Okay, it doesn't look very difficult, Vaisa. What I'll do is I'll just copy this here and we'll come back in about 10-15 minutes, inshallah. Let me just copy that first. Okay, this is a relatively easier one now, so we'll try to get done with it quickly. We have a number of other questions to do after this as well. Okay. So we have a namaz break. My writing is extremely bad. I'll do is I'll type it. Okay, so we have a short break now. When we come back, we will inshallah do this question and more after that. Okay, everyone, let's look at this one. We were doing difficult questions from these three papers. This is the next question that we're doing from November 25, paper 1-1. Have I opened the wrong hole? No, it's okay. Question number 5 from this paper, November 25, paper 1-1. This is the next question that we're doing from this particular paper. Actually, it doesn't look very difficult to me. So what I'll do is I'll just maybe make some equations and then tell you to do that after that. Okay. It doesn't look very difficult, so I'll try to be quick about it. And in AP, the first term is 3, so it's an arithmetic progression. It's an arithmetic progression. A is equal to 3. The sum of the first 10 terms is 4 times the sum of the first 5 terms. Okay, so that means S10, that is equal to 4 times S5. What's the sum formula for an arithmetic progression? It looks like this, half n into 2a plus n minus 1 times d. That's the sum formula for an arithmetic progression. Okay, you input values in this. Input values in this, see what that gives you. S10, that will be half into 10 into 2 times a, the value for a is 3 plus n minus 1, that is 10 minus 1 times the difference. What's the difference? Difference is what we have to figure out. We have to find the difference. So that equals 4 times half into 4, half into 5, that's S5, plus 2 into 5 plus n minus 1, which is 5 minus 1 times the difference. Okay, let me just check the working again. Half into 10 into 2a plus n minus 1, which is 10 minus 1 times d. And the other side, we've got 4 times 1 over 2 into 5, 2 into 5 plus, yeah, it looks okay. Let's simplify this now. This gets cancelled to give you 5. On the other side, 2 and 4 get cancelled to give you 2 here. Now, multiply 5 inside here. On the other side, by the way, we also have this 5, right? So we can cancel out that 5 with this 5 as well, right? So it's a non-calculator paper, so it'll make things easier. Now, inside we're left with 6 plus 9d on the left side. On the right side, we just have this 2 left outside. Multiply that 2 inside, 2 into 10, that will be 20, plus 2 into 4 times d, and that will be 8d. And that will give you the value for d, and that is 14. That's our final answer. I think I wanted to do just the first few parts, but we ended up doing the whole question. That's what we were looking for in the first part. ठीक है, इसमें कोई मसला तो नहीं है. I think that was fairly straightforward as long as you are careful about your working. There's a careless mistake somewhere. Okay, achha, let me check again. S10 half into 10, that's 2 into a, which was 6. That's okay. Plus n minus 1 times d, 10 minus 1 times d. We have 4 multiplying outside into sum of the first 5 terms, half into 5 into 2 into, I'm sorry. I multiplied by 3 there, 5 there by mistake. It was supposed to be 3. This was supposed to be 3 here. This was 3 here. And that becomes 2 into 6, which is 2 into 6, which is 12. And then d equals 6. Yeah, sorry about that. D equals 6, that's the value of d that we end up getting from this. ठीक है, that's what we were looking for in this part. ठीक है. Let's move on. Now they're saying hey, the first, second, and fifth terms. The first, second, and fifth terms of another arithmetic progression. They are the first, second, and third terms of a geometric progression. It's given that the first term of the progressions are not 0. Find the common ratio R of the geometric progression. Walaikum assalam, Uzair. I hope you're doing well. You joined late today. Arithmetic progression. So we have another arithmetic progression, a different arithmetic progression. For this we know The first term, the second term, and the fifth term, as in we don't know them, but we have a relation of these terms with the first three terms of a geometric progression. The terms of a geometric progression that they correspond to are the first, second, and third terms. So T1, T2, T3 of the GP. The first terms are the same. The second terms are the same. The fifth term of the AP is the third term of the GP. Now, given this, we need to find the values. We need to find the values of A and R. We don't have A as well. In fact, we just need R, the ratio. How can we do that? What's the nth term formula for an AP? It's A plus n minus 1 times D, right? And the nth term formula for a GP, AR raised to power n minus 1. Input values. We just know the value for n, right? So for AP, we could say this is A, this is going to be A plus D, and this is going to be A plus 4D. For the GP, this is going to be A, this is going to be AR, and this is going to be AR squared. Now, A is equal to A. That does not give us anything interesting. But these two we can say are equal. So that gives us one equation. A plus D is supposed to equal AR. And A plus 4D is supposed to equal AR squared. Yeah, these are supposed to be equal to each other. We get two equations from that. A plus D equals AR. And we get A plus 4D equal to AR squared. These are two equations that we end up getting from this. We know the value for, do we know the value for anything here? We don't know A, we don't know R, we also do not know D. We have three unknowns, right? We have three unknowns. Do we have another piece of information given? The first terms are not zero. That is one thing that we know. And the first terms are the same. Okay, let's see what we get from this. If we can eliminate something from the first equation, we could say D is equal to this, and that will give us something in terms of only R. Maybe something might just cancel out. A might just cancel out. Let's just start working. From the first equation, I could say if I divide A on the other side, that will give me A plus D divided by A. A plus D divided by A. Let's input that in the other equation and see what that gives us. It becomes A, or instead of that, since we want to find the value for R, let's make something else the subject. I will make A the subject or D the subject. Let's make D the subject. D equals AR minus A. Let's input this in the other equation. Let's input this in the other equation and see what that gives us. This gives us A plus 4 into AR minus A, and that is equal to AR squared. Let's hope something gets cancelled. Yeah, so that's what is happening. That is what is happening. Each term has an A in it. Okay, so from the original equations, it looked like we can't solve these two equations because there are two equations and three unknowns. We have A, D, and R. Generally, we need three equations to be able to find three unknowns. In this case, however, what happens is if I put D equal to AR minus A in the other equation, A is appearing in every single term now, and that will get cancelled. So if I simplify this, this gives me A plus 4AR minus 4A equals AR squared. Now A is appearing in every single term. So if I just divide the whole equation by A, I can do that, right? Because A is not zero. The first term is not zero. If it's not zero, I can divide by that. So it gets cancelled, and I'm just left with 1 plus 4 times R minus 4 equals R squared. And that's an equation that we can solve, and it's a quadratic equation. How do we solve this? R squared minus 4R. This is 1 minus 4, which is minus 3. Minus 3 goes to the other side. It becomes plus 3 equal to 0. Can we factorize this? Yes, R squared minus 3R minus R plus 3, that is equal to 0. That gives us two factors, R minus 3 and R minus 1. There are two possible values of R that we're getting, R equals 3 or R equals 1. Now, R is not equal to 1. The question also tells us that. So this is not possible because if r is equal to 1, that means every term is just the same, right? We just keep multiplying by 1. So that's not an interesting sequence. The question also tells us that r is not equal to 1. So the value of r is going to be 3 for that reason, and that's our final answer. Okay, so its working was not very difficult. It's just that when you get stuck at this point that there are three unknowns, just continue with the working and you realize that it just can the value for a the constant a that just cancels out. Okay, chalo, let's move on. That was question number 4 from this paper or 5 from this paper. We did 4 before this. That was a very interesting question on functions. Let's look at the next one now. So we're done with 5 now. What's the next one from this paper? Question number 9. Okay, let's do that. Question number 9 from this paper. Let me copy this here. That's the next one that you guys asked about. Okay. So it says the diagram shows the velocity. The diagram shows the velocity time graph for a particle moving in a straight line. On the diagram below, okay, that's only the first part. On the diagram below, the speed sketch the speed time graph for the motion of this particle. Okay. The graph is a velocity time graph. Now we need to draw a speed time graph. What's the difference between a velocity time graph and speed time graph? Velocity is a vector quantity, so it can also be negative. Speed can never be negative, right? Speed is a scalar quantity, so that cannot be negative. So all we have to do is this part of the curve that is below the x-axis, below the time axis, just make that positive. Reflect that in the x-axis. It's like taking modulus of that function, right? Because speed is supposed to be positive. So it's intersecting the x-axis somewhere around here. The right side of the graph is going to look the same as before. That is not going to change. So make a similar shape to the original shape on the right side. So it looks more like this. On the left side, reflect this graph. Okay, when you reflect it, it is going to look something like this. It's too high. Yeah, something like this. That's what the graph of, or make the gradient more zero there as well. This is the speed time graph that we wanted to draw. That's one mark. This is all that you had to do. The examiner should clearly understand that you've drawn the same thing on the right side. And on the left side, you've just reflected this part. And that will be acceptable. Okay. Yes, it will be reflected. So that was part A. Let me copy the other part here as well. Okay, now this is the second part. Now they're saying it is given that the velocity time graph is part of a quadratic curve. Okay. So this curve that you have, it is part of a quadratic function. So it's a U-shaped graph, right? It'll look like this on the left side. The curve has gradient 0 when time is equal to 0. Okay. Now, velocity time graph, gradient represents acceleration. So acceleration when time is 0 is equal to 0. Sketch a possible acceleration time graph for the motion of the particle on this diagram. Achha. So what do we know about acceleration now? One thing that we know is that the graph is going to start from 0. Right? That's something that is given. The gradient is 0 at this point, so it starts from 0. Now, what is the shape of the graph going to look like? They told us it's a quadratic function. If it's a quadratic function, so that means V is going to be equal to like this, AT squared plus BT plus C, something like this, right? It's a quadratic function. When you find the derivative of this, when you find the derivative of a quadratic function, what does that look like? It's going to be a linear function. It's going to be a straight line. Straight line with a positive gradient. Why? Because you can see on the graph, gradient throughout is positive. Initially it is zero, but then it's positive gradient. Gradient of a velocity time graph represents acceleration. So gradient is positive. All you have to do is make a straight line with positive gradient. Now, we don't know what the actual value for that gradient is going to be. So we just draw a random straight line like this, just making sure that the gradient is positive, and that will be okay. Okay. Makes sense, right? Chalo, let's move on. That was question number 9 from this paper. That was not that difficult. Next one from this paper is 12. Okay, last question from this paper, question number 12, and then we move on to the next paper after that. Let me copy this as well. Okay, question number 12. Let's try this. Okay, then the next paper that we're doing after this is paper 1-3 from the same session. That's the last paper. We will do difficult questions from that paper as well after this. Chale. It says the solutions to this equation by accurate drawing will not be accepted. Okay. Relative to an origin O, the position vectors of the points A, B, and C are given by this. O is this, OB is this, OC is this. Where K is a scalar constant, so that's just a number. C lies on the line AB, that is given to us. Use a vector method to find the ratio AC to AB. Okay. Draw a random line AB. In fact, we had given the points 1, 7, and 7, 4. So we can maybe mark them somewhere. If this is a point 1, 7, let's say. B 7, 4, it will be on the right side and below. So maybe somewhere around here. This is the point B, which is 7 and 4. Okay. These are 2 points, A and B. They are saying on this line AB, there is a point which is C. Now, we don't know where exactly that point is going to be. All we know is that C has coordinates like this, K times 1, 2. Let's just mark that anywhere here on this line. Let's say this is C. ठीक है. अच्छा. Now, we need to find the ratio AC to AB. Ratio AC to AB. How do we think about this? These 3 are collinear points. These are collinear points, A, C, and B. That means the ratios of corresponding components are going to be the same, or you can say the gradients are going to be the same for AC, AB, and CB. All of these are going to have the same gradient. Since they're talking about these two, let's just use that. AC and AB. They are going to have the same gradient. We can use that first of all to find the value for K. And once we have the value for K, then finding the ratio is not going to be very difficult, right? Let's find the value for K first of all. See what that turns out to be. How do we do that? First of all, find the vector AC. See what that turns out to be. AC vector, that will be OC minus OA. OC minus OA. OC can be thought of as K into 1, 2, that is K and 2K, minus OA, which is 1, 7. This simplifies to K minus 1 and 2K minus 7. That's the vector AC. Find the other vector as well, which is AB. Let's find that vector. What is AB? AB is just OB minus OA, right? OB minus OA. We can write that directly as well. This is just 7 minus 1, which is 6, 4 minus 7, which is minus 3. These are the two vectors. Now, since these 3 points are collinear, the corresponding components should have the same ratio, or you can say the gradients are supposed to be the same. So we put their gradients equal. Gradient of AC, that is 2k minus 7, change in y, that's change in y, right? Divided by change in x, k minus 1, that equals minus 3 divided by 6. And that will give you the value for k. Cross multiply. Before cross multiplying, let's simplify this. It becomes 2 here. Do not forget the negative sign. We can take 2 to the other side, and that gives us 4k minus 14 on the left side. On the right side, we have this negative multiplied by k minus 1, and that will be minus k plus 1, which is 5k equal to 15, and the value of k turns out to be 3. So now we know the value for k is 3. Okay, the value for k is 3. Now, if the value for k is 3, now we have the vector AC. We have the vector AC now. What is the vector AC going to be? This vector AC, it was k minus 1 and 2k minus 7, right? Let's input the value for k in that. 2 into, no, 3 minus 1 and 2 into 3 minus 7. What does that simplify to? It simplifies to 2 and negative 1. That's the vector AC. Okay. The other vector is AB. We also have that. That's 6 and minus 3. AB vector is 6 and minus 3. You can just visually see in this case, if you multiply this by 3, you get 6 minus 3, right? So the ratio of these two vectors is like this. AB vector is 3 times AC. Now, since they are parallel vectors, whatever is the ratio between their vectors, it will be the same ratio between their magnitudes as well. This is the ratio of the magnitudes, right? There's no vector sign on top of that. So they're talking about the length AC and length AB. There's no vector sign on that. So what's the ratio of the lengths now? Ratio that they mentioned there was AC to AB. Okay, what I can do is I can write it like this. AC, ratios of their magnitudes, that is going to be AB equal to 3 times AC. That's the ratio of the magnitudes. And then AC over AB. What's that? That's 1 over 3. So you can therefore say ratio AC to AB, that is 1 ratio 3. Now, you don't have to show all of this working. I just did that to make sure that you understand the process. You can skip some of these steps. For example, right after this, you can actually directly write this answer. Right? You can just see that that's the answer, that's the ratio. Do not write 3 to 1, that will be wrong. It's 1 to 3 because AC is smaller and AB is bigger. They asked you to find the ratio AC to AB. That's 1 ratio 3, not 3 ratio 1. Okay? And that's our final answer, 1 to 3. Okay, that was the last question from this paper. Let's look at the next paper now. Next paper, this was November 25, paper 1-1. Now we're doing difficult paper questions from this one last paper, November 25, paper 1-3. Tomorrow we're doing difficult questions from all the June papers, inshallah. June 25, paper 1-1, 1-2, 1-3. You'll be letting me know in the WhatsApp group using the same polls which questions you find difficult from the June papers as well. Okay, so we'll discuss those specific questions, and then you can come with any of your other general questions as well. It'll be a longer session tomorrow. For now, let's just do this last paper for today. November 25, paper 1-3, difficult questions from this. Actually, I'm looking at the poll again. Okay, there seem to be some more questions from this paper now, a bigger number of questions from this paper. Let's start with them. Okay, first of all, we've got question number 3 from this paper. Question number 3 from this paper. Let me copy that here. Okay, question 3. Let's start with this. Okay, so they're saying in this question, you may use the values in the table below. Okay, values x and y are related by this equation, y equals sine 5x, where x is between 0 and pi over 10. Okay, we need to use calculus to find the approximate change in x when y increases from under root 3 over 2 by the small amount 0.01. Okay, so this is approximate change. Now, first of all, let's find the derivative. Let's find the derivative. We are given the function y equals sine 5x. Let's differentiate it and see what we get from that. What's the derivative of sine? Derivative of sine is cos, so it becomes cos 5x multiplied by the derivative of 5x, which is 5. So it simplifies to 5 cos 5x. Okay. This is the derivative that we're getting, 5 cos 5x. Now, what we are supposed to use eventually is this change in y over change in x. That is equal to dy over dx, right? That's approximately equal to that. Now, dy over dx at that particular point, the problem is we have the value for y given. It's not the value for x, remember, it's the value for y that is given. In the derivative, we have x as the variable. So corresponding to that y value, we first need to figure out what the x value is going to be. Let's figure that out. Let's see what the x value is. This is what we will use later then. Now, what's the x value? The function was y equals sine 5x. Input that y value under root 3 over 2. That equals sine 5x. Sine inverse of under root 3 over 2. Now, this is why they gave you that table above, so you can use those values, use values from that table. Sine inverse of under root 3 over 2. When is sine under root 3 over 2? At what value of theta? Sine is under root 3 over 2 and theta is pi over 3. So this becomes pi over 3 equal to 5x. And the value for x that we get from this, that is pi over 15. Now, this is the value of x that we would input in that derivative to find dy over dx. dy over dx. The value for dy over dx turns out to be 5 into cos of 5 times x. That means 5 pi over 15. Now, 5 and 15 get cancelled to give us 1 over 3. So we have pi over 3. What is cos of pi over 3? It's a good idea to memorize these values as well, but they've given us the value here. Cos pi over 3. Cos of pi over 3. That's this value, 1 over 2. Okay, that's what we use here. It's going to be 5 into 1 over 2, which is just 5 over 2. Okay, this is the value for dy over dx that we're getting. Once we have got dy over dx, we have the change in y given as well. Change in y is 0.01. We have to find the change in x corresponding to that. We can do that now. Just input values in this, and that should give you the result. Okay. Approximate change in y, that is going to equal 5 over 2 times, change of y is given. We have to find change in x. Change in y is 0.01. Change in x is what we have to figure out. Okay, change in x goes to the other side. This gets multiplied by 2 over 5. 0.01 into 2 over 5. That equals change in x. Okay, simplify this and that will give you the result. How do we simplify this? Calculator is not allowed. Remember, there are multiple ways of doing this. You could convert this to decimal and that will be 0.4, multiply 0.4 and 0.01. Just change the decimal places to something like this, 0.004. That's one idea. Or you could convert that decimal to fraction, write 0.01 as 1 over 100 and do it like this. 2 and 100 get cancelled to give you 50 there. And the change in x, that turns out to be 1 over 250. You can leave it like this if you want. If you want to write decimals, that's also okay. It will become 4 over 1000, right? Which is 0.004. Both of them are fine. You can leave your answer as a fraction, or you can write a decimal. Both should be acceptable. Okay. That was question number 3 from this paper. The key thing to understand here was we were given the value for y here. So to find the value for x, to find the derivative dy over dx, we had to first find the value for x from that. Then you input that, and you also had to use values given in the table here, the exact values given. Okay. I hope that makes sense. Let's look at the next one. This was question number 3 from this paper. The next question from this paper that you guys asked about was question number 5. Okay, let me open that now. Let me copy that now. Question number 5. Okay, here it is. Okay. Now they're saying the normal to this curve at the point where x is equal to 0 cuts the curve again at 2 other points. Find the x coordinates of these 2 points. X coordinates of points of intersection. How do you find points of intersection for any two functions? You solve them simultaneously. We have the equation of the curve given already. What we have to do is we first have to find the equation of that normal, and then we would just solve that simultaneously with this equation. Let's do that. Let's see what happens. Find the equation of the normal first of all. We have the function given. The function is y equals x cubed plus 3 over 2 into x squared minus 2x plus 1. That's the function. To find the equation of the normal, we need to find the derivative of this. We also need that point. We have the x value given. The value for y is just going to be 1. You can see that directly. I'll just write that on the side. When x is equal to 0, the y value that you get from that is 1. So the point at which we are looking for the normal's equation is 0, 1. Okay. Let's find the equation of the normal first of all. Dy over dx, what's that? That's 3x squared plus 2 gets multiplied, and that gives us 3 times x, right? Minus 2. That's the derivative. To find the gradient at this point, you put that value of x equal to 0. The gradient at this point is 0 plus 0 minus 2, which is minus 2. Okay. Or you can just write down minus 2 directly as well. That's okay. Achha. Now we know the gradient at this particular point of the curve. What's the gradient of the normal going to be? Negative reciprocal of this. Change the sign, take reciprocal, and that will be 1 over 2. Now we've got the gradient, we've got that point. We can write down the equation of the normal, right? This is the y-intercept, 0, 1. That's a point on the y-axis. So we have the y-intercept already. We can write down the equation of the normal. That will be y equals mx plus c half x. That's the equation of the normal, right? This is what we have, plus 1. Half x plus 1. That's the equation of the normal. Okay. Achha. Now, once we've got the equation of the normal, remember this was c, right? This is the y-intercept. C is equal to 1. Now we have to solve it simultaneously with this. Now, it's a cubic equation. When we solve it simultaneously, we would get a cubic equation. How do we solve cubic equations? The good thing about this is that we have plus 1 here, we have plus 1 here. They will get cancelled out, and we can just factorize x outside, factor x outside, and that will make it a quadratic factor. Okay, so it's not that complicated. We have this normal's equation now. The equation of the original curve, I'll just write that down on the side here as well. That was x cubed plus 3 over 2 x squared minus 2x plus 1. So we have the equation of the normal, we have the equation of this curve as well. We want to figure out the points where this curve and the normal, they intersect each other again. So we solve them simultaneously, their equations. When we equate them, that gives us x cubed plus 3 over 2 x squared minus 2x plus 1. That equals half x plus 1. Take all terms to the left side. X cubed plus 3 over 2 x squared minus 2x minus half x. That will become minus 5 over 2. Or if you want, you can also make it simpler. Just multiply the whole thing by 2 in the previous step. Multiply by 2, 1 gets cancelled. Multiply by 2 so that the fractions get eliminated. Since we are doing it without a calculator, it will make it easier and less prone to errors if we avoid fractions. Multiply the whole equation by 2, that's what I'm doing, so that the fractions get eliminated. 2x cubed plus 3x squared minus 4x. On the other side, we've got x. Now this becomes 2x cubed plus 3x squared minus 5x equal to 0. It's a cubic equation now. How do we solve this cubic equation? We can take x as a factor outside, as common outside. That leaves us with 2x squared plus 3x minus 5, that equals 0. So that means either x is equal to 0 or 2x squared plus 3x minus 5 is equal to 0. Can we solve this quadratic now? 10, can we factorize? Do they want x coordinates? They do not mention anything about the exact values. We can't really factorize. Oh, we can factorize this. What am I thinking? We can factorize this. 2x squared plus 5x minus 2x minus 5 equal to 0. That becomes 2x minus 2. No. That becomes x minus 1 and 2x plus 5. These are the two factors that we get from this. X is equal to 1 or x is equal to minus 5 over 2. These are the two solutions that we get, and that's our final answer. They just wanted the x coordinates. If they also wanted the y coordinates, you could input these back in this normals equation. You'll get the y coordinates as well, but they just asked for x coordinates. That's your final answer. Not that complicated. That was 8 marks, right? That's a lot of marks for just this. ठीक है. Okay, so I think it was probably just voted because it was 8 marks without being split into parts. Otherwise, it wasn't that complicated. Let's look at the next one now. Okay, acha, maybe I looked at the wrong poll. Okay, I'm sorry. I was looking at the wrong poll. There weren't any votes on this. Acha. How do we know when to take x common, when to solve it using long division or synthetic? You always check if x can be taken common because that will simplify it. When there's no constant term, if there's no constant term, like in this case, there's no constant term, you can take x common. But if there was a constant term as well, if there was a constant term as well, in that case, you could not take x common. ठीक है. Acha, so it looks like I was looking at the wrong poll. This wasn't a question that had any significant number of words. Okay, so this was an easy question actually. Let's do 6. 6 is the next one that we want to do now. Question number 6. Let me copy this here. Question number 6. Okay, question number 6 from this paper. This is part A. And this is part B. Okay, let's try this. It says the diagram shows an equilateral triangle ABC. An equilateral triangle ABC with side A. M is the midpoint of AC and angle AMB is 90 degrees. Use the diagram to find secant 30. Okay, how do we do that? Remember, secant is reciprocal of cos, so this is 1 over cos 30. Now, those of you who remember the value for cos theta, the value for cos theta is under root 3 over 2. If we just write it here and say the value of secant 30 is 2 over under root 3, that's not acceptable. You will not get marks for that. The question says use the diagram. Use the diagram to find secant 30. So if you remember the value and you write it down directly, that's not allowed. Okay, that's not allowed. You have to show how you get that value from the diagram. Okay? So cos 30 is what we're looking for. Now, where do we get the angle 30? This is 60, right? This is equilateral triangle. This is also 60. If we have a right angle like this, that angle on top will be split into two parts. This will be 30. And the other side will also be 30. Now, let's focus on this right angle triangle, the one on the left side. It's a right angle triangle. If this value is A, it's an equilateral triangle. This full length was A as well. What about this length? This will be half A. How do you find cos of this angle? Cos of this angle is going to be adjacent over hypotenuse. So we need this length, BM. Can we find that length? We can find that length. We can use Pythagoras for that. We could say BM squared plus half A whole squared, that equals A squared. Okay. Now that gives us BM squared equal to A squared minus 1 over 4A squared. That will become 3 over 4A squared. Take square root and BM turns out to be under root 3 over 2 times A. Make sure that the under root is only on 3 here. If you put the under root on the whole thing, then the numbers should just be 4 in the denominator and this should be A squared. A lot of people are careless about it. So even after, or let's say if they write it directly with the whole under root 3 over 4 with A outside only, they end up just putting the square root on the numerator. You lose marks if you do that. Make sure that you're careful about it. Okay? If the square root is on the whole thing, make sure that it looks like it is on the whole thing. If it's only on the numerator, it should look like it is only on the numerator. That's the value of BM that we have got. Once we've got BM, now we could say this is under root 3 over 2 times A, right? So what's the value of secant 30 now? What's the value of secant 30 now? Secant 30 is 1 over cos 30. What is cos? Cos is base over hypotenuse. So that will be under root 3 over 2 times A divided by A. A and A get cancelled. 2 goes to the numerator. And we get 2 over under root 3. And that is your final answer. This is what we were looking for. Okay, so you have to show this working. You have to show this working. Otherwise, it will not be. Otherwise, it will not be acceptable. Okay. Achha, that was part A. Let's look at the next part now. Show that this expression can be written as 2 cosecant x into cot x. How can we do this now? No, if you write down the answer directly, that's not acceptable. That is not acceptable. The question says use the diagram. So the examiner needs proof of that working. It needs evidence of that working. Maximum, you could get 1 mark for that. Yeah, maximum you could get 1 mark for that out of 3. You will definitely lose 2 marks if you don't show the working. Achha, what about this now? 1 over secant x minus 1 plus 1 over secant x plus 1. We have to write it like this. Let's take LCM. Let's take LCM. Secant x minus 1 into secant x plus 1. In the numerator, we have secant x plus 1 plus secant x minus 1. Now, secant x minus 1 into secant x plus 1, that's a minus b into a plus b, right? We could write it as a square minus b squared, a square minus b squared. So I'll just directly write it as secant square x minus 1 in the denominator. Achha, now in the numerator, what happens is we get 2 secant x. Okay. In the denominator, secant square x minus 1. Can we simplify this somehow? Secant square x minus 1, does that remind you of something? Does that remind you of something? 1 plus tan square x is secant square x. If you rearrange that, you get tan square x identical to secant square x minus 1. So we could write this thing as tan square x. Okay. What do we do now? We have to convert it to that form somehow. Now 2 is already there, right? 2 is already there. 2 is already there. The problem is, how do we convert this to this form now? We want cot there and we want cosecant there. Okay. I think it will be a good idea to convert everything to sine and cos. It becomes easier to think about. We can do some cancellations then, right? Secant, what is secant? Secant is 1 over cos. Let's just write it like that. 1 over cos x. Tan squared in the denominator. That will become sine square over cos squared in the denominator, right? Cos square I can write in the numerator. So it becomes cos square x divided by sine square x. Right? That makes things simpler to understand. This tan squared in the denominator, I have written that as cos square x over sine square x. Okay. Now cos x and 1 power of cos, they get cancelled. And what we have is 2 cos x in the numerator. And in the denominator, we have sine square x. We don't want any squares there. So what I'll do is I'll split it in 2 parts. I'll say cos over sine x into sine x. And now we could say cos over sine. What is this? This is cot. This will give us cot. And sine in the denominator, what's the reciprocal of sine? Reciprocal of sine is cosecant. So this therefore can be written as 2 cot x into reciprocal of sine, which is cosecant. That's the same thing as if you rearrange it, you can also write it as 2 cosecant x into cot x. Right? That's the same thing. That's the same as the right hand side. And that is what we wanted to prove in this question. Okay. Now, in problems like these, there are always multiple ways of doing this. So you could use some other method as well. You'll still get to the correct result. That is okay. Okay. You got full marks without using the diagram. Okay, a couple of people saying they got full marks using the diagram. Let me just show you the marking scheme. Most likely it will say it's not acceptable. I'll just confirm. Art Maths. Which paper was this? November 25, paper 1, 3. That's the question paper. So which question are we doing? We're doing question number 6. Acha, first part. So they're saying on the side B2, these are all marks that you have to write the exact thing and only then you would get that mark. So one mark is for using this a squared minus a squared over 4. You won't get this unless you're using the diagram, right? And then you have 2 marks for this working. Either this or this or this. So this is all coming from the diagram. So if you're not showing this working, you don't get marks for that. So it's clearly written in the marking scheme. That's required. ठीक है. Okay, chale, let's move on to the next one. This was question number 6. This was question number 6. Let's look at the next one now. The next question from this paper that you're asking about is question number 7. Question number 7. This is part A. Part B. Okay, let's do this. This is the most asked question from this paper. चलें, ये देखते हैं. The point O is the origin. The point O is the origin. 2 points P and Q are such that PQ vector is in the same direction as minus I plus 5j. Okay, so PQ vector is parallel to this vector. It's some multiple of this. R is such that OR is in the same direction as PQ. Okay, so OR, PQ, and this vector, they're all in the same direction. Magnitude of OR is 3 under root 26. Find the vector OR. How do we understand this? These are all parallel vectors. PQ vector and OR vector and minus I plus 5j vector. These are all parallel vectors. Now, can we write OR vector? Can we write OR vector in terms of this vector? If it's parallel, if it's in the same direction, it should be a multiple of this. That means k times something. So we can write OR vector as k into minus I plus 5j. Right, so that becomes minus ki plus 5kj. That we can multiply this vector with some number, let's call that k or any other letter, doesn't matter. And that will become vector OR. Now we are given the magnitude of OR is 3 under root 26. So what we can do is we can find the magnitude of this vector now. See what that turns out to be, minus k whole squared plus 5k whole squared. Square root of that, this must equal 3 under root 26. And that should give you the value for k. You can see what that is. K squared plus 25 k squared, that will become 26k squared. That equals 3 under root 26. Under root 26 into k. That equals 3 times under root 26. And that gives you k equal to 3. That's the value of k that we were looking for. Achha. Once we have the value for k, input that back now in that OR vector. What's the OR vector going to be then? Minus 3i plus 5 into 3, that will be 15 times j. That's the vector OR. Okay, this is one way of doing this. You could also find the unit vector for this. That could be an alternative. Find the unit vector from this vector. then multiply that by 3 under root 26. That could be an alternative. That will also work. Okay? So you make the magnitude of this vector 1 and then multiply that by this. Or in fact, just find the magnitude of this vector directly. This is actually under root 26. And then you can just visually see that this is getting multiplied by 3. That will actually be very efficient. Now that I think of it, I thought of it. You could actually just find the magnitude of this vector. Minus I plus 5j, find the magnitude of this. That turns out to be square root of 1 square plus 25, which is square root of 26. Now, the magnitude of this vector is square root of 36. We want a vector in the same direction that has this magnitude. How do you go from under root 26 to 3 under root 26? Just multiply that by 3, and that gives you minus 3i plus 15j, and you get the answer directly. Right? You will get the answer directly from that. That becomes pretty efficient, right? Okay, let's move on. Let's move on to the next one. Let's look at the next one now. Now they're saying OP is in the same direction. OP is in the same direction as 2i minus 3j, and OQ vector is this. Find the vector OP. Okay, now this is another parallel vector. So I was reading that wrong. I was just thinking they're saying OP is in the same direction as this vector, and it is also in the same direction as this vector. That's not what they mean. They've just given another vector OQ. What is Q? Acha, we had Q given there. We had PQ given. Okay, all right. So what they're saying now is OP is in the same direction as this. So we can say OP vector is equal to K times 2i minus 3j. Okay. OQ vector is given. That is 10i plus 6j. That vector is given. In the first part, we were given that PQ is parallel to this vector. PQ is parallel to this vector. That was another thing that we were given. PQ is parallel to that vector. Okay, so could we make it simpler somehow? So there's a longer way of doing this that will work. There's a longer way of doing this, but could we do it more efficiently? Actually, let me write down the information that we've got. PQ vector is parallel to minus I plus 5j. Okay. This will be some different K. We can say this is K1, this is K2. Into minus I plus 5j. This is parallel to this, and that vector is parallel to this other vector. What we can do is we can find it in terms of that first, and then, yeah, okay, let's do it this way. So this is an efficient way of doing this now. Let's not introduce two constants. Let's just stick with this. So first of all, we are given the vector OP, we're given the vector OQ. What we can do is we can say, let's find the vector PQ from this. We can find the vector PQ, right? PQ vector, that's going to be OQ minus OP. What does that turn out to be? 10i plus 6j minus k into 2i minus 3j. Okay, that will give us something. Let's see what this turns out to be. 10i plus 6j, that is 10i minus 2ki plus 6j minus or plus 3kj. Okay? This is what the vector PQ turns out to be. Now, they told us in the question that PQ is parallel to this. What we can do is we can write the I component for this separately. I component is 10 minus 2k. J separately, the J component is 6 plus 3k. This is supposed to be parallel to, this is parallel to minus I, we can think of that as minus 1i, right? Minus I plus 5j. It's parallel to that. If it's parallel to that, what that means is their gradients are supposed to be equal. Their ratio is going to be equal to each other. Ratio of corresponding components or gradients. You can use any of those. So gradient of PQ, what is that? 6 plus 3k divided by 10 minus 2k. That should equal 5 over minus 1. Okay, that will give the value for k. Once you've got the value for k, input that value of k back here, and you'll get the point, the vector OP, the position vector of P. That's what we were looking for. Okay, let's do that. Let's cross multiply. This gives us minus 6 minus 3k. That equals 50 minus 10k. 7k equals 56. The value for k turns out to be 8. Once we've got the value for k, input that back here in OP, and that will give you the result. Okay, that's the vector OP that we were looking for, and that's our final answer. Okay, I hope that's helpful. We will have a break for 1 minute. There's a Azan going on here. Then we do a couple of more questions before we end. 1 minute break and then we'll see. Okay, so there are a few more questions. That are there in the polls that you guys voted for. Let's do them and then we end for today, inshallah. It's been a long session. Question number 9. That's the next one. Okay, it's not very difficult. So we'll try to be a bit quick on this now. Okay, so we have log of 5x minus 2 base 5, that minus log of x base 25, that is equal to 1 over 2. We have to solve this equation. Bases are different for the two logs. Let's use the change of base law to make the bases the same. Let's make the base 5 for both of them. For this one, we could say we have log of x base 5 in the numerator and log of x base 25 in the denominator. Sorry, what am I doing? Log of 25 base x, base 5 in the denominator. Okay. We use the change of base law to make the bases 5 for all of the logs. Now let's simplify this. Let's simplify this a little. This denominator you can evaluate, right? What power of 5 gives you 25? Or I'll just do one more step for you. In the numerator, we've got log of x base 5. In the denominator, I could write this as log of 5 squared base 5, right? What does that become? That just becomes 2. So the denominator is 2. On the other side, we've got 1 over 2. Let's multiply the whole equation by 2 so we get rid of fractions, and that will give me 2 log of 5x minus 2 base 5 minus log of x base 5 equals 1. That's the equation that we've got now. Now, it's the same basis. It's the same base for both the logs. We can use division law now. But before we can use the division law, we need to get rid of those 2 outside the first log. How can we do that? We can take that 2 to the power. So it becomes 5x minus 2 power 2 basis 5 minus log of x base 5, that equals 1. There's a minus outside log. Using division law, it will become 5x minus 2 whole squared divided by 5 basis 5. Now this 5 goes to the other side, becomes the base of 1 in the power form. This goes to the other side. And that gives me, in the numerator, we've got 5x minus 2 whole squared. Let's not expand it because it'll be simpler to do it directly without expansion. In the denominator, we've got 5. Do we have 5? Okay, I've done an error here. I'm sorry. This is not 5. This is x. In the denominator, we had x there. So it's always a good idea to, check the previous 2-3 steps after every few steps, to spot errors like this. So I had written 5 in the denominator here. Thankfully, I spotted that jaldi. Okay, so now that 5 goes to the other side. And that becomes 5 raised to the power of 1. Achha, now in this case, we will have to expand because we have 5x on the other side. So taking square root is not going to be helpful. So what I'll do is I'll just expand the numerator in the same step. That gives me 25x squared minus 20x plus 4. Now x goes to the other side and becomes 25x squared minus 20x plus 4 equals 5x. And we get this equation, 25x squared minus 25x plus 4 equal to 0. Okay, this is what we're getting. Can we factorize this? We cannot simplify this equation. We cannot divide by any number to make it smaller numbers, right? 25 into 4 is 100. We can get 100 by multiplying 20 and 5. So it will become 25x squared minus 20x minus 5x plus 4 equal to 0. We can break the middle term like this, take 5x common from this, that leaves us with 5x minus 4 inside, take minus 1 common, that leaves us with 5x minus 4 inside. And we get two factors, 5x minus 1 and 5x minus 4. X is either equal to 1 over 5 or it is equal to 4 over 5. Whenever you get multiple answers, always check if you can input them back in the equation. Okay, we have 5x minus 2 inside the log. We have to be careful. Can we input that? We can't actually. So 1 over 5, if we put that in the first log, it will become 5 into 1 over 5 minus 2, which is negative 1. So the first log is going to become undefined if x is equal to 1 over 5. So for that reason, we need to cross out this answer. This is not possible. 1 over 5 is not possible. 1 over 5 is not possible. So the only possible answer therefore is going to be 4 over 5. And that's your final answer. Okay. Makes sense, right? This was part A. This was part A. You can quickly verify this as well on your calculator. It's a 5-mark question. Okay, I'm sorry. Why do I forget every time a calculator is not allowed? Okay, we can't verify this. You can verify manually if you want. That's not too hard as well, let's say. Input 4 over 5 and that will give you log of 2 base 5. minus log of 4 over 5 base 25. Okay, it's not that straightforward as well. It will take some time to verify. Okay, so that's okay. That's the final answer that we've got. The second step with reciprocal law. You want me to do the second step with reciprocal law? Uh, that would not help, right? Reciprocal law, that's a special case of change of base law that we use when we have to switch the base and the argument. That's not what we want to do here, right? We don't want to switch the base and the argument. If we use reciprocal law here, that will become log 1 over log of 25 base x. Is that what we want? That's not helpful, right? Because we still have different bases. This is 5. This is x. That's not going to help. ठीक है, अच्छा, let's move on. Part B. Part B of this. How do we do this now? That's a 6-mark question. अच्छा. E raised to power 3y minus 7, e raised to power 3y minus 7. I think it's a good idea to take a substitution right away in the beginning because we've got the variable is only in these powers. There's this power and there's this power. So you could also separate out. Oh, I'm sorry. Why am I reading this wrong? This is minus 7, this is minus 1. So we can't do that. I thought that they were both the same. Okay, we have to split it first. We can say e raised to power 3y. Let's split it. E raised to power 3y into e raised to power negative 7 plus 4 over e raised to power 3. That equals 5 over e raised to power 3y into e raised to power negative 1. Now we can do this. We can say e raised to power 3y, e raised to power 3y. Take a substitution for that. Okay. You could separate out e power y as well by writing it as e power y whole cube. Or you can just do substitution for this. You can say let some other letter, u maybe, that equals e raised to power 3y. Okay. So then this equation would become u into e raised to power negative 7 plus 4 over e cube equals 5 over u into e raised to power negative 1. Okay, you have to be careful with algebra here. That's why it has 6 marks. It's just a bit complicated working, tricky working that will make you do careless errors if you try to do it very quickly. So slow down a little, make sure that you're writing every step correct without careless errors. Okay, what can we do now? What can we do now? Let's take LCM on the left side. Let's take LCM on the left side. E cube, multiply that here. What will that become? U e raised to power minus 7 into e raised to power 3. That becomes e raised to power minus 4 plus 4 over e cube. You could also take this to the denominator if you want to make the powers positive. That's also fine. Let's do it that way, actually. So a lot of people get confused with negative powers. Let me take that to the denominator. U over e power 7 plus 4 over e cube on the right side as well. This is negative power. I can take that to the numerator, so it becomes 5e divided by u. Okay. This is what we get. Now, what's the LCM of the denominator? What's the LCM of the denominator? Highest power of e is 7, and we have u. We can multiply the whole thing by e raised to power 7 times u. Multiply the whole equation by that. Or you could take LCM on the left side and then cross multiply. That's also fine. You can directly multiply this by this as well. That will make it quicker. The first term, what does that become? The first term becomes u squared. The second term, when you multiply it by this, e power 4 gets multiplied there. So you have 4e power 4 times u. On the other side, we have 5e raised to power 8. Okay, this is what we get. It's just a shortcut instead of taking LCM on both sides. I'll just do that as well in case it confuses anyone. Take LCM on the left side, that will give you u plus 4 e raised to power 4. And then you cross multiply. When you cross multiply, you get this thing directly. Okay. So that's what I was doing in one step. Now this is a quadratic equation. It's a quadratic equation. Let's bring that to the left side. 4e power of u, 4e power 4 times u minus 5e raised to power 8 equals 0. Now, can we factorize this? If you can't, if you find it difficult to factorize, input in the quadratic formula. It will need some simplification, but it will eventually work. But we can factorize this as well because this is minus 5. We can break it into minus 5 and 1. That minus 5 and plus 1. So the middle term can be broken like this. U squared minus 5e power 4 times u plus e power 4 times u minus 5e raised to power 8 equals 0. If you find that difficult to do, input values in the quadratic formula and then simplify. You can solve it like that as well. That's perfectly okay. Now, from the first two terms, I can take u common. That leaves me with u minus 5e raised to power 4. From the last two terms, I can take e power 4 common, and that also leaves me with u minus 5e raised to power 4. Now, the two factors that we've got are u plus e raised to power 4 and u minus 5e raised to power 4. That equals 0. So either u is equal to minus e raised to power 4 or u is equal to 5e raised to power 4. Now put that substitution back. Let's put that substitution back now. U equals e raised to negative e raised to power 4. Okay, I'm sorry, where was that substitution? U equals 3 e raised to power 3y. Let's put that back. E raised to power 3y. That is equal to minus e raised to power 4. Or e raised to power 3y, that is equal to 5e raised to power 4. Now we need to figure out the values of y from this. How do you figure out the values of y? This is not possible, right? If you try taking log on both sides, think about taking log on both sides. This will be undefined on the right side, right? E power 4 is a constant. Negative constant, you can't take log in this case. So this is not possible. This is not going to give you any solutions. What about the right hand side? What about the right hand side? Now we have this 5 multiplying here as well. Otherwise, we could compare the powers, right? So in this case, we can't compare the powers. What do we do then? We can take log on both sides. Take log on both sides, ln base e. ln e raised to power 3y. On the right side, we have ln 5 e raised to power 4. Now 3y will come down and you get 3y ln e. On the other side, we have 5 e raised to power 4. That's a product. We can use product rule on this to expand it. Or you can leave it like this as well. Let's say there's, although it's generally a good idea if you have e inside ln to simplify further. So let's do that. ln 5 plus ln e raised to power 4. We split it into two parts. On the left side, we just have 3y left, right? Because ln e is 1. On the right, we have ln 5 plus 4 ln e, which is just 4. And the value of y, therefore, at the end, that turns out to be ln 5 plus 4 divided by 3. And that is the final answer that we get. Y equals ln 5 plus 4 divided by 3. Okay, that was 6 marks. It deserved 6 marks because there was quite a lot of working indeed. Okay. No, there is a problem somewhere. Sure. Okay, let me check my working again. There's an error somewhere. E raised to power 3y into e power minus 7 plus 4 over e cube. That is fine. I did the substitution, that became u over e power 7. And then plus 4 over e cube plus 5 e from the denominator, that's okay, divided by u. So it looks okay until this point. Then we took LCM u plus 4 e power 4. On the other side, there was 5e, so divided by u. Cross multiplied u squared plus 4u e raised to power 4. That is equal to 5 e raised to power 8. We bring everything to one side. Okay. Okay. So there was an error here. There was an error here. This was plus. For some reason, I wrote that as negative in the next step. Okay, again. So that is something that you need to avoid. So this was plus. I wrote that as minus for some reason. Let's erase all of this and do it again. Achha. So we have u squared minus e raised to power u squared minus e raised to power 4. This was supposed to be plus here. U squared plus 4 e raised to power 4 times u minus 5 e raised to power 8. Can we factorize this? Can we factorize this? This is minus 5 and 1. 5 and minus 1, they will work, right? 5 and minus 1 will work. So this will be u squared plus 5e raised to power 4 times u minus e raised to power 4 times u minus 5 e raised to power 8 equal to 0. Okay, so we can factorize it like this. We can factorize it like this. Otherwise, you can use quadratic formula as well. That will also be okay. Now, the first two terms give me u into u plus 5 e raised to power 4. The last two terms, they give me minus e raised to power 4 common. That leaves me with u plus 5 e raised to power 4 equal to 0. Now, there are two factors that we get from this: u minus e raised to power 4, u plus 5 e raised to power 4. That is equal to 0. One value of u that we get is u equals e power 4, and the next value that we get is the other value that we get is u equals minus 5 e raised to power 4. Now put that substitution back now. What was the substitution? U equals e raised to power 3y. Put that substitution back. So it will become e raised to power 3y equal to e power 4. On the other side, we have e raised to power 3y equals minus 5 e raised to power 4. Now this is not possible on the right side, right? Because we cannot take LCM. We cannot take we cannot take log, sorry. We cannot take log on the right side. It's a negative sign. Positive number, any power of that can never be negative. So the second equation that we're getting here, that's not possible. This does not give you anything. Now the first equation is very straightforward to solve now because it's the same base. We can just equate the powers, and that will give us 3y equal to 4, y equals 4 over 3, and that will be the result. And that's actually fairly straightforward. That was 6 marks, not a lot of working. As long as you are not making any careless mistakes, that was pretty straightforward. Okay. Okay, that was question number 9 from this paper. Any issues? Any problems? Okay. Next one from this paper is question number 10 and then 11. 10 and 11. Okay, so I'm pretty tired now. You tend to do more careless errors as well when you get tired. Let's do the next one. Okay, 10 and 11. These are last two questions and we end with that then. And I'll see if I can maybe just give you an overview of these if they are easy to solve after that. question number 10, part A. Okay, the second part is pretty long. At least the statement is pretty long. Part B. Let's copy this as well. Okay, part B of this question. Question number 9 from this paper. This is question number, no, this was question number 10. Question number 10 from this paper. Now they're saying there's an arithmetic progression that has first term A and common difference D. First term is A and the difference is D. Given that we have this, find A in terms of D. That's straightforward, right? Just input values in the AP formula. Half into 20 into 2 times A plus 20 minus 1 times the difference. That should equal 3 times 1 over 2 into 10 into 2 times A plus n minus 1. That means 10 minus 1 times the difference. Okay, this is what we get. Let's simplify this. On the left side, we have 10. On the right, 2 and 10, they give us 5. We can do more simplification. 5 and this 10 is simplified to 2 here. Now, 2 into 2A, that is 4 times A plus 19 into 2, that will be 38 times D. On the other side, we just have 3 left outside, right? 3 into 2A, that is 6A plus 9D. We want A in terms of D. A needs to be the subject. 2A equals 29 times D, and the value of A is 29. Okay, I did not multiply that here. That's too many careless errors at this point. Okay. 4A plus 38D. On the right side, we had 3 into 2, that was 6A. 3 into 9D, we had to multiply 3 there as well. 3 into 9, that is 27 times D. Okay, so that becomes 2A equal to 11D. And the value of A turns out to be 11 over 2 times D. And that's our final answer. Is what we were looking for in the first part. Okay, just apply the sum formula, make A the subject, and that gives you the result. Okay, that's part A. Let's look at the next one now. Let's look at part B now. Now they're saying a geometric progression A has common ratio R, where modulus of R is less than 1. What that means is its sum to infinity can exist, and it's a convergent sequence. The terms of these progression are given A1, A2, A3. Another geometric progression B has these terms such that B1 is equal to A2, B2 is equal to A4, B3 is equal to A power A6. The sum to infinity of A is SA, the sum to infinity of B is SB. Find this ratio of their sum to infinities. Give your answer in its simplest form. Okay. So what we have is one geometric sequence that looks like this. Now this looks complicated, but I feel like its working is not that complicated because you see the first GP, its terms are A1, A2, A3. We can write down the sum to infinity for this. They call this SA. What's the sum to infinity? A over 1 minus R. We can write down the ratio for this as well. Ratio of the sequence is going to be A2 over A1, right? That's the ratio. Okay, let's just start and see what happens. A over 1 minus R, the first term is A1 divided by 1 minus A2 over A1. Can we find the connection between their ratios as well? Because if you see, if we have A1 and A2 here, I'm just thinking, if this ratio is R, because that will make it much quicker then. Yeah. Okay, so a more efficient way of doing this could be, we have two geometric progressions. The other geometric progression, let's write that down as well. This is A2, A4, right? The first term is A2, the second term is A4, the third term is A6, and so on. These are the terms of this geometric progression. What's the ratio of the first GP? Let's say it's this, right? This is R. This ratio is R for the first GP. This is R. The next term after this, that is going to be A4. This is also R. Now, how do you go from A2 to A4? You can see in order to go from A2 to A4, what you have to do is R into R. You have to multiply by R squared. So the ratio of the other sequence is just going to be R squared. So if for one sequence it is R, for the other sequence it is going to be R squared. So we can write it like this. Now, let's write down the sum to infinity for both of them in terms of R, right? Because otherwise those fractions will become complicated. SA. What's the sum to infinity for the first progression? This is A, and this is geometric progression B. Sum to infinity for the first one, that will be A1 over 1 minus R. And for the other one, SB, that is going to be A2 over 1 minus R squared. Yeah, this is what we end up getting from this. Yeah, so geometric progression, the first one had ratio R, right? So we want everything to be in terms of R. Okay, now can we somehow write A2 in terms of A1 so that when we find the ratio, because eventually what we have to do is we have to do the ratio SB over SA. So SB over SA, this is what we want to do at the end, right? Now, in order to do that, can we somehow make both of them the same so they end up canceling out? Can we write them in terms of R somehow? A2 can be written as A1 times R from the first sequence. From the first sequence, from the first progression, I could say A2 can be written as A1 times R. So SB I could write as A1 times R over 1 minus R squared. Now, why am I doing that? Because when I calculate this ratio now, what would happen would be, I would get, write it separately, A1R over 1 minus R squared, that's SB, divided by A1 over 1 minus R, right? Now this becomes A1R over 1 minus R squared into 1 minus R divided by A1. I could actually write this denominator 1 minus R squared also as 1 plus R into 1 minus R, right? A square minus B squared, that's A plus B into A minus B. And now what happens is A1 and A1, they get cancelled. 1 minus R and 1 minus R, they get cancelled. And we're just left with R over 1 plus R, and that's what we wanted. That's our final result. That ratio that we were looking for is just SB over SA. And that's our final result. That's 5 marks. And that becomes pretty efficient if we do it like this. Is that okay? Okay. So we were looking for the ratio of these geometric progressions. That's the final result that we end up getting from this. That was question number 10 from this paper. Let's do one last one that you guys asked about. And that was question number 11. Let's do 11, and then we end with that. Question number 11. Let me copy that as well. Last question from this paper. It's the circle equation question now. Okay, last one for today. The circle equation question. Let's try this. Okay. Now they're saying the lines x equals 0, x equals 4, y equals 3, y equals -1. They are tangents to a circle. Find the equation of the circle. Now these are all horizontal or vertical lines, right? These are vertical lines, these are horizontal lines. So if we had a circle, let's say it looks like this. Vertical and horizontal tangents. Where do we get horizontal and vertical tangents? Horizontal tangent would be one on top and one at the bottom. And the vertical tangents would be one on the left side and one on the right side. These are the tangents that we're given. Now, the vertical tangents, the smaller one is x equals 0, and the one on the right side, that's x equals 4. And the one with the smaller y value is -1. So this is y equals -1, and the bigger y value, that is y equals 3. This is what the circle looks like. How do you write down the equation of the circle? For equation of a circle, we need the radius of the circle. What's the radius going to be? We can clearly see from -1 to 3. How many units is that? That's 4 units in total. So the diameter is going to be 4. The diameter of the circle, that is going to be 4. So the radius is 2. Radius is 2 units. Okay. Radius is 2 units. What about the center? Because once we have the center, then we can write down the equation. Where is the center going to be? You have the values on the x and y axes, right? On the y axis, this is 3, this is -1. Center is going to be exactly in the middle. On the x axis, this is 0, this is 4. And again, center is going to be exactly in the middle of them. So we could say the center of the circle, that is going to be 0 plus 4 over 2. That's the x coordinate. And -1 plus 3 over 2, that's the y coordinate. That will be exactly in the middle of the vertical tangents and the horizontal tangents. And the center, the coordinates of the center, they turn out to be 2 and 1. So we've got the center, we've got the radius, we can write down the equation of the circle. X minus a whole squared, that means x minus 2 whole squared plus y minus b whole squared, y minus 1 whole squared equals r squared. That means this 2 squared. And that's the equation. That's easy 3 marks in the first part. Now, if you sketch that, it makes it much easier to understand. Okay. All right. Now, what next? Now they're saying the line y equals 2x plus a, where a is a constant, is also a tangent to the circle. Now, this is not horizontal or vertical. It's an inclined line, right? It's a slanted line. Given this, we need to show this somehow. Okay. And hence find the possible values of a as well, giving an answer in the exact form. Okay, how do we think about this now? So we found the equation of the circle. We found the equation of the circle in the first part. That was x minus 2 whole squared plus y minus 1 whole squared. This was the equation of the circle equals 4. Now there's a line that is a tangent to the circle. Line is a tangent to the circle. Does that remind you of something? Line is a tangent to the circle. Line is a tangent to some function. If it's a function that has powers 2, quadratic, similar to what quadratic function, discriminant b square minus 4ac is equal to 0, right? That is what you can use here. That's one way of solving this. You say, let's input this in the other equation first of all. So to use discriminant, generally what we do is we start the process. We start the process of solving the equation simultaneously. We put y equals 2x plus a here. Let's start with that. Put y equals 2x plus a. Now, if we actually do it here inside the bracket, it's going to make things complicated. What I'll do is, let's expand it first. Let's expand it and then do that. Let's expand this first. If we expand this, we get x squared minus 4x plus 4. Otherwise, expanding 2x plus a minus 1 whole squared, that would have become a bit more complicated. So I'm just saying, let's expand it first. So it gives us y squared minus 2y plus 1, and then minus 4 from the other side as well. That equals 0. And this simplifies further to x squared minus 4x plus y squared minus 2y plus 1 equal to 0. 4 and minus 4, they get cancelled, right? Okay. Now at this point, let's input this thing. At this point, let's input that. So now we get x squared minus 4x plus 2x plus a whole squared minus 2 into 2x plus a plus 1 equal to 0. This simplifies further to x squared minus 4x plus 4x squared plus 2 into 2x into a. What will that be? 4ax plus a squared minus 4x minus 2a plus 1 equal to 0. ठीक है? This is what we're getting. Let's simplify this a bit. Write the like terms together. So we have x squared minus 4x. We have to be careful. I put square on top of that for some reason. This is x squared minus 4x. I'll just check my working again. X squared minus 4x plus 2x plus a whole squared. That looks okay. And then minus 2 into 2x plus a plus 1. Okay, seems okay. All right, now let's add the square terms, x squared plus 4x squared. That gives me 5x squared. This is 5x squared. And then the x terms, we have minus 4x, 4ax, and minus 4x. Let's write them together first. 4ax minus 8x. Okay. And then the constant terms that do not have any x with them, they are a squared minus 2a and 1. Is that what we wanted at the end? Yeah, something similar to that. Let's write that here. Plus a squared minus 2a plus 1 equal to 0. We wanted to show that it can be written like this. Can we write it in that form? 5x squared, we can take 4 common outside. That leaves us with a minus 2 and x is common outside. That's fine. That's this term. A squared minus 2a plus 1. This is a perfect square. A squared minus 2ab plus b squared. We can write this as a minus 1 whole squared. That equals 0. This is one thing that we had to show first of all. That's quite some work for 4 marks because we still have to find the possible values of a. So we equate both of them first. We equate them, simplify that, and that gives us this. Now, since the line is a tangent to the circle, what does that mean? B square minus 4ac must equal 0. So we put b square minus 4ac equal to 0. So therefore, we have 4 into a minus 2 whole squared minus 4 into 5 into a minus 1 whole squared equals 0. 4 squared, that is 16, into a squared minus 4a plus 4 minus 20 into a squared minus 2a plus 1. That equals 0. This simplifies to 16a squared minus 64a plus 64 minus 20a squared minus, or in fact plus 40a minus 20 equals 0. Simplify this further and that gives us minus 4a squared minus 24a plus 44 equals 0. We can divide the whole thing by minus 4 and that will give me a squared plus 6a minus 11 equal to 0. We want to give our answer in exact form. Okay. We can't factorize this. Minus 6 plus minus square root of, that's a lot of working for 4 marks. 6 squared minus 4 into 1 into minus 11 divided by 2 times 1, which is minus 6 plus minus square root of, what does this become? 36 plus 44. 36 plus 44, that will be 80, right? Square root of 80 divided by 2. Now we can simplify this because 80 can be written as what's the highest factor which is a perfect square? 25 is not. 16 is a perfect square. 16 is a perfect square. So we could write it as square root of 16 into 5, right? And then 4 can be written outside. 4 into square root of 5 divided by 2. And that simplifies further to minus 3 plus minus 2 under root 5 when it is divided by 2. These are the two possible values of A that we're getting. Okay, that was pretty long for 4 marks at the end of the paper. Second last question on the paper. This is how you could do it. Okay, makes sense. That's it. I hope that was helpful. We did all the difficult questions from these 3 papers today. November 25, paper 1-1, paper 1-3, and March 25, paper 1-1. We have these live sessions happening almost every day until your second exam, paper 2, on 26th. These are free past paper sessions. If you want to join, you can look at the link in the description of this video. Just fill your details there and you'll be added to the WhatsApp group. The timings are shared in the WhatsApp group. How you can join that group is by filling out this form that I've now pinned in the chat as well. Fill out that form. It'll be added to the WhatsApp group. I'll be assigning what papers to attempt for each day, and you're supposed to attempt them before. And then when we discuss them, you can ask any questions that you might have as well. Okay. You'll find a lot of other resources in the description of this video as well, like difficult questions from a number of recent papers and revision videos, a lot of revision videos that a lot of students find helpful every single year. All of that is there in the description of this video. Okay, share this with your friends as well so more people can benefit. I will see you in the next session tomorrow, inshallah. Tomorrow, what we're doing is we're doing 3 papers, difficult questions from 3 papers, June 2025, papers 1-1, 1-2, and 1-3. Okay, those are 3 papers that we're doing tomorrow. Difficult questions from those 3 papers. I'll see you again tomorrow, inshallah then. Allah Hafiz.